Hello, hello, I'm audible. Hello, hello. Yeah, okay, thanks. Yeah, good evening, all. So, we'll discuss today about week six content. So, last 2 weeks, week six and week seven live interactive session, we have postponed today and tomorrow due to actually I'm not available in here. So, yeah, it's fine. I hope you have answered all of the questions about the assignments week 6 and week 7. So, yeah. So today we'll discuss about the week 6 some questions, and the week 6 is related to a topic of um, artificial intelligence, means that is artificial neural network. What is an perceptron and what is an multi-layer perceptron, which is the core or base of the deep neural network, or we can say that if artificial intelligence. And so, yeah, and also in this week, Dr. Pabita has discussed about the kernelization of the SVM, why we require the kernelization. That in the last our discussion, we have also talked about the why in the overlapping case of the binary classification, or it is an non-linear classification problem. It's not we can't directly find the linear separable boundary in between the two classes. In that case, we are using the kernel actually. Kernel we are trying to use for the to transforming low dimensional data to a higher dimensional data, so that our overlapping cases gets will get a separated will get a boundary which is separable in between the classes. Yeah. So this is an some introduction about the why we are using the kernelization, what exactly the kernelization does, right? Yeah. So these questions we'll discuss about the ANN, which is an artificial neural network. And if in between you have any doubts, please let me know. Okay. I think we can start now, right now. Yeah. So moving towards the question one, the question one states that artificial neural networks can be used for which of the tasks. So there are three tasks has been mentioned: the pattern recognition, classification, and clustering, and fourth one is an all of the above. So what do you think that which task can be done by the artificial neural network? As Dr. Pabitra in his lectures, he has also mentioned some examples which can solve by the ANN, which is and face recognition, right, for the biometric verification, right? And also it is find the gesture of the face. If you are giving input to artificial neural network is an one image, and we need to find that is a face image. We need to identify that particular user, what is his name, and what we can say, or what is his an age. Also there is another way we can find, we can detect that what is his emotion in that particular image. It is an happy, sad, or excitement, right? These emotion can be also we can find, right? Pattern recognition, how we can detect or recognize a pattern. So let's take as an one example that we have a set of x-rays, and there are some x-rays are there which has and some cancer patient x-rays are there, and some x-rays are there, remaining x-rays are the normal people x-ray who does not have an cancer, right? So artificial neural network can utilized to find a pattern, what exactly the pattern for a particular x-ray, which can be denoted as and which can be represented as an cancer patient x-ray, right? It is helpful for to recognize a pattern in between the uh, example set of the examples for a specific task. In a classification we have also see that how the uh, what is an exactly the classification task. Actually, we have seen the spam, non-spam, that particular email is an spam email or not spam email. It has a classification problem, right? And the clustering, it means that we have a set of unstructured, or we can say we have structured data and which does not have an categories, labeled category. We need to cluster a set of examples which has the same properties, right? So let's take as an vehicle. In the vehicle, there are cars are there, and bikes are there, trucks are there, right? And each of these categories has their specific attributes are there. The car is and that length, and which has an four uh, what we can say four wheels, and the bicycles has an two wheels, bike has an two wheels, and it has a length which, like this, and it has consumed the petrol in some uh, capacity, right? So using these properties, we need to cluster the three clusters. We need to cluster the three set of the clusters, which represents different categories actually, based on the attributes, right? So considering these, so all of these tasks can be handled by the artificial neural network. So it is used for pattern recognition, classification problems, clustering as well. Okay. So here option D is correct. Okay. Is there any doubts in this question? Okay. Let's move to the another question. So here in this question too, it states that a perceptron can correctly classify instances into two classes, where the classes are overlapping, linearly separable, non-linearly separable, and none of the above. I will elaborate what exactly the overlapping, linearly separable, and non-linearly separable. So it is, this question is discussing or talking about only a perceptron, single perceptron, not as an multi-layer perceptron, right? As we have seen in the lectures, that perceptron is used to classify or to uh, do a task for a specific classification as well, a single perceptron, right? So this is an x1 one output, x2 output. There are a lot of input attributes maybe, right? And it is providing a classes, which is an two classes are there, right? So it gives a score, right, which is in between 0 to 1, right? It is greater than threshold, the score, and we can say, so this is a threshold and this is an our target value, or we can say it is an uh, output value t. T is greater than z, right? So it is an class 1. Is less than equal to z, right? Then in that case it is an 0, right? T is less than z equal z, then in that case it's 0, right? So we have seen that is an, this is an this threshold, and greater than this threshold it is an 1, and less than this threshold it is an 0, right? So overlapping means, suppose we have a two-dimensional data we have two attributes, let's consider as an x1 and x2, and these classes has overlapped here. Okay, so this is option one. That is, it is stating that the both of the classes are overlapped together, right? So can be this perceptron, single neuron can solve this problem. The two classes are overlapped. In that case also, it classifies correctly two classes. So that is the question has been asked for the overlap. So another is an linearly separable. Suppose you have a data x1 x2 and which is linearly separable, means you can see here that is an the two classes, the plus and this circle one is which has an distinguishable in between in the representation you can see, and it is an linearly separable. There is a no non-linearity separable in between the classes. So this is option 2. And option C, it states that you have two features. Okay. So one x2 and which is a non-linearly separable, like this one and this one. Okay, it's not overlapped here, but it is an non-linearly separable. Okay, so you can see the separation line could be like this way. Okay, so what do you think, which option is correct in this case? In single perceptron console, which of the cases, or it solves none of the above? What do you think? Yes, anyone? So as you can see, the linear single perceptron, yeah. Next. So the single perceptron, it has been used. It treat likes as an to classify cases which are separable. So let's see here. So it will solve this B option, the linearly separable cases, because this is a single. This is not it. The single perceptron solve an easy task actually. If it is a non-linearity, in that case, how this artificial neural networks can solve these problems? So we have seen that for that there are multiple neurons, multiple perceptrons combined together to solve the to solve this non-linearly problem actually, which is an some bit complex, right? So by using the each of this perceptron, this multi-layer, which we are calling this is an multi-layer perceptron, right? Which is a fully connected network, or we can say as an mm, what we can say feed forward network as well, right? So it is all of this information goes in single direction, right? So how this non-linearity will solve by using the multi-layer perceptron? As you can see, there are multiple cases are there. So you can see the first new perceptron will draw this is an one separable line. The second perceptron may be second layer of the multi-layer neural network, which draw an this separable line. Another perceptron can be used to draw this is an what we can say, this is an another boundary separable line. So combining multiple perceptron, we are trying to solve a non-trivial problem, right? Which is an such as a non linearly separable task, right? Non linearly separable classes. So in this case, we can use a multi-layer person. Also, in the overlapping cases, also the multi-layer person at a certain period of time, it can help actually. Yeah. So the single perceptron solve only the linear separable classes effectively. Okay. Yeah. So here option B is correct. I hope you guys understood, right? Okay. So let's move to the another question. So in question 3, it states that the logic function that cannot be implemented by a perceptron having two inputs. Okay. As we have seen in the lectures, the logics means there are multiple operations we are did in circuits, right? The and, or, nor, XOR. As we have seen that we have a single neuron which has two inputs. Okay, that is an x1, x2. This x1, x2 belongs to 0 or 1. Okay. So considering this, and we have and perceptron, we know that the nomenclature, which is an x1 and x2 input, which has an associated weights as well, w1, w2. Okay, and this is our output. We can say that we need to adjust a weight such a way that we can get a and operation output. We can get a or operation output, nor at XOR. Right. So let's take as an we can adjust. Suppose here we have taken 1 1, then it is used to solve as an AND operation, right? If it is a 0 1 like this, or 0 0 0 1 is fine, right? 0 1, it is used to do an OR operation. Same like for non as well, nor as well. But in the case of the NOR XOR, we have we have you can see, or let's try to understand by the uh, diagram, that will be easy to get as in how we can so how that single perceptron used to solve the multiple operations. So in A, that we have two inputs. Let's take as an x1 and x2. Let's take here 0 0, right? And here 1 0, here 0 1, and here the point is here, which is an 1 1. As we have previously in previous question, we have seen the perceptron is used for to distinguish or to it can solve a linearly separable points, which is an we can draw a linear line in between the uh, two classes, which will get a correct classes, right? Here you can see as and operation, that 1 1 gets as an 1, so right, and other as an 0, right? In that case only the linearly separable line is fine for this case, right? So it can easily draw by the single perceptron to get as an 1 1 value as an 1, right? This is one class and this is an zeroth class. Same for the XOR. So the same, like this is also true for the XOR, right? The another is an uh, what we can say is 1 1 and mm, second 0 1, right? Second best pointer is 0 1 1 1 and 1 0 0 0. So in this case also this linear line is fine, right? Because here is an zeroth class and here is an one class, right? So this is B. C is option also. That is, you can say that is 1 0 or right. That means is an if it is input is only single input is there here. If it is input is a 0, then you will get as an 1, and input is a 1 only single, and you will get as an 0, right? Means it is an depends on the how you are adjusting the W here. But in the case of the XOR, you may observe that we have multiple cases, that you can see for this point 1 1, and this is an 0 1, this is an 1 0, and 0 0. These two are 1 1, right? These two are 1 1, and these 1 1, and it is in zeroth class. So you can see we can't directly we for a single linear line we can classify effectively these 2 points, right, which is in 1 1 and this is in 0, right. So you can see, you can draw this line, though it is also not classified correctly all of the instances. So we require two lines here, and that is not in the hand of the perceptron, a single perceptron, right. It requires a, that already discussed, FNN, feed forward network. Okay, FNN, or multi-layer perceptron, we can say that. So here the option is that it cannot be solved, which is an XOR operation. Okay, so because the perceptron, it the artificial, you can see that ANN, artificial neural network or multi-layer perceptron, it can solve this problem, but it has an uh, no, but single perceptron can't handle the XOR operation, which has a non-linearity. Actually, you can see here is a non-linearity. There are multiple lines or multiple linear lines we require, separable boundaries we require. That is not in hand of the a single perceptron. We require greater than two neurons, greater than or equal to. So that's why the XOR option is correct, which is not handled by the single perceptron. Okay, yeah. Okay, let's moving to the another question, which is states that a training input X. Okay, we have a set of X instances, X inputs are there, which is used for a perceptron learning. Okay, the desired output is T, and the actual output is O. And if the learning rate n and the weight update performed by the learning rule is described by, so which one is a learning rule, that you maybe remember that, and which one is a correct learning rule, right? So what is an exactly the learning rule is here, as we have saw. So we have X input is there, and in the X there are set of input instances are there, x1, x2, x3, x4. So this is an inputs are there. For each of this input there is associated label is there, like y2, y3, y4, right? Understood? So here the y1, it is they are calling as an 0 oo, that is an actual output for a single in for a respective example x1. So this is an O actually, right, for a single output. And it is actual, means it is a ground truth label. And there are, by using our multi-layer perceptron, that is an artificial neural networks, right, network, we have neurons, multiple neurons. By using this multiple neurons, we will get a derived or a desired output by by taking this input, we are getting some output, right, by using the multi-layer perceptron, and that output represented as an T for each of the example. Okay, so this is an model, or we can say our multi-layer perceptron MLP output. Okay, so we need to get the we need to design a neural network such a way that we'll get as an actual output, right. So that is in hand, as we have the gate calculation or gate that AND operation, for performing the AND operation or operation, we are not manipulating input, actual input, right, we are manipulating a W which is associated for a respective input, right? We are manipulating a W or changing the W such a way that we'll get a desired output, or we for a actual output, actual class, right? So as you can see here, we have a single perceptron and which has two inputs, okay, and which has associated weights are there w, and this is a bias, right? Bias, and we'll get a output from it, which is an let's take as an let's it is an t here. So this is a single perceptron, but we are talking right now about the uh, multi-layer perceptron. So in this case also, the single perceptron also, we need to tune this W1 and W2 such a way that we'll get as an a T as an uh, uh, actual classes, actual correct classes. Right. In the multi-layer perceptron as well, so this is an inputs, our x1, x2, x3, x4. Okay. Depends on the particular our inputs. Sorry. So this is an fully connected network. So I'm drawing randomly here, but it is an all of the nodes connected to its previously connected nodes. Sorry. Okay. Right. And this one is an you will get as an T. Right. Each age has associated weight is there. So we need to update this weight based on whatever output we are getting and what is the actual output O is there, right? If it is the error is high, then we need to update this value. If it is there is zero error, then does not need to update this W and W1 and W2. So this is an actually learning rule that we are finding here. Learning rule means we need to update W such a way that we'll get as an correct classes from the neural network, right? So this is an learning rule actually here, right? So here, as already taught about the, we need to minimize the error or a difference between the derived t and the actual output, derived output and actual output. That means it is an t minus o. Okay. So this needs to minimize, and that should be is uh, is also included in the update rule, right? This if the difference is less, then we need to little bit update the or increase the previous weights, right? If the difference is high, then in that case we need to update or increase the previous weight more, right? Yeah. So considering this, what do you think that which one is an learning rule is correct in this perceptron learning rule? So we have a T derived or desired output, which is we will get from the multiple perceptron, and O another attribute which is an actual output. Also, they have given that is a there is a learning rate. It is an N. So considering these parameters, what do you think that which one is an learning rule is correct? So here we are updating a WI. WI means a weight associated to a particular age. So here W1, W2, W3 likewise WI. So we are updating a weight using our previous weight plus delta W, or we can say W, delta W. Okay. So here you might be think that you are updating a new W. Means we are getting the new W by using a previous W. So you might be think what could be the values of the initial W. So if we have considered this x1 and x2, first of all we need to specify the W1 and W values, right? And after the getting the uh, mm, output by using this W1 and specified W1, we need to update that W1 and W2, right? So first of all we need to mention or specify a W1 and W2 initially, right? That initialization we are doing here for various W's in multiple perceptron, which are the random initializations. Okay. Random values we are specifying for respective W's. Okay. So first of all, for randomly, and then we need to see what could be the desired output. Based on that desired output, what is we need to calculate the error. What is an exactly error in between? Based on this error, we are updating the our W, respective W. So here that already said that this is a previous W and this is an our error. How much we need to update this previous W? It is in less, it is in great higher, or it is no need to update it. Okay. So this depends on this delta W. So delta W, how we are calculating it, which is an eta into t minus o to x. So this is an error which is an associated how much x we have to add into a W actually into a new updated value. And this is an eta, that is a learning rate. We are saying that learning rate means how much we need to jump it out. Okay, means only I need to impact for this learning rate. What means what we can say, whatever values we are getting, how much we need to impact on our WI. Suppose you are giving point not one, so it scales down to point not one, and which will update this point, scale the point not one with this WI, right? So here you can see the options here. Which one is correct here? That is an here the eta is not there, right? So that's why it's not correct here. Here the WI is previously WI is not mentioned, so it is not correct. Here you can see the x, t minus o, eta, and wi, has been mentioned. So here B option is correct. Okay. I hope you guys understood. Yeah. Okay. Yeah. So let's move to the next question. Yeah. So yeah, you can. This is also trivial question. You may read this question carefully and think on that and which one is an correct option for this question. Let me know, and after that we can also discuss it this question plus. But before that you may take some time and please read this question, try to solve yourself, and then we can have a discussion on this question. If you have any doubts or any concern, please let me know. Okay. Yeah, please read the question carefully and try to solve this question. Hmm. Yeah, Nilu. Mhm. See. Yes, any other students expect from the Nilam? Any other possible answers here? Option B, option D. Okay, so here let me read this question. Suppose we have n training examples and xi is given, which is an xi is an input or instance, you can say input feature for a specific example, that is I. I is 1 to n, whose desired outputs are ti associated, which is associated with each of the example xi, x1, x2, x3, such that t1, t2, t3, like we have discussed in previous question. The output of a perceptron for these training examples xis are y, which is I equal to 1 to n, O1, O2, O3. As we have already saw what exactly the T is and what exactly the O is. T is derived or desired outputs we are getting from our neural network. And the O here represented as an actual output of respective examples, right? Which is a ground truth, we can say that. The error function minimized by the gradient descent perceptron learning algorithm. We have seen that what exactly the gradient descent algorithm is, right? So which is helpful in a deep neural network to get as an a weights, to get as an uh, weights which will give a lesser error. Lesser error means that whatever the neural network we have designed, that is an suppose two hidden layers are there, which is an fully connected layers are there, and there are weights is associated with the all of these edges. We need to find out the uh, what we can say, we need to find out the or approximation of the weights, so that we'll get as an correct result, correct class. Okay, so for getting a perfect or correct or expected w, we are using a two learning rules. Perceptron learning that we have seen in previous slide, previous question, and another is an gradient descent. So gradient descent, which is, you can see that in lectures as well, we have seen that x1 and x2. We are, sorry, w1 and w2 for two weights we are considered here. Okay. So let me w1 and w2. So for each of this w1, w2, how much error we are getting? This is an error. Right? So maybe this one, this one, this one, right? So these are the points. At this point of period of time, the w1 this and w2 is this, and at that time we are getting this much of error. So we need to find these weights, which we will get lower error, right? So the gradient descent, it includes back propagation as well. Back propagation means that same like that how we are updating the bits. We are going forward firstly, then we are getting a desired output. Based on this desired output, we are getting the errors. Errors means the T is desired, right? And the O is an actual. We are finding the what exactly the difference between the desired or derived output and the actual output. Based on this error, we are going back of the network of each of the neuron from, and we are updating each of the output, each of the weights. That is an back propagation we are doing. After updating all of the weights, then we are trying to again, we are trying to see what exactly output we are getting. Like this way, we are, this is a training process, right? So here we are talking about in this question, as we have seen that T is an desired output, which is an, or we can say derived output, and actual output. We are taking as and getting as an, we need to find as an error, how much error. So that error we are trying to find by using these formulas. We need to find which one is an correct option for getting as an error. The error function minimized by the gradient descent perceptron learning is, so these, from these four options, there is one correct error function which is used by a gradient descent perceptron learning algorithm, that we need to find out. As we have seen that, we know that, that is, it should be a difference, right? It is an desired output, right? And it is an actual output. It should be a difference out there, right? So considering this, what do you think? Yeah, the Neelam has said that the C option. Yeah, that is an correct option actually. So why not the D option is correct? Because from this, the maybe one of the option is correct, right? But this should not be correct, because it is an, they did the addition, that it's as an inverse of whatever our assumption, right? We require a difference in between the desired one and actual one. So why not this one, the D option? Because you can see in this option, in this uh, equation, you will get a minus values as well. That will mislead our uh, mm, uh, update rule, right? So we require whatever the values we are getting, that is and should be the positive values, right? So that's why we have added as an the square value that will remove the negative values here, right? Yeah. So this is an correct error function that is used for to minimize the gradient, to minimize the error by using the gradient descent perceptron learning algorithm. I hope you guys understood. Is there any doubts in this question? Okay. If not, we'll let's move to the next question. So yeah, the question 6 states that tanh activation function is, yeah, take your time. Please let me know what could be the correct option. This is a very trivial question actually. Right? So that what exactly the activation function might be, you confused about that. So activation function, that, as we have seen that there is a single perceptron. Let's take as an a single perceptron which has inputs w1, w2, sorry, x1, x2, associated weights, and this is an bias, and you are getting as values. So here we are summing the all of these weights. Summing means we are doing that x1 into w1 plus x2 into w2 plus w3. So this is summation we are did here, right? And this, let's take as an, this is one z1, right? So we are doing this z into what we can see, passing in, which is, this operation can be done in this perceptron actually. It combines all of these weights along with the its input features. But you are getting some score here, right? That maybe goes, it is an infinity score, right? It gives an any values here, right? As we have seen in previous question, that is a threshold activation function is there also. Threshold means if this z is greater than your threshold theta, then it is an 1. If it is less than, then it is an 0. This is a simple threshold activation function we have used to get as an what we can say, to get as an to get an 1 or 0 value. Okay. So here, so the same we have seen that is, and there is an sigmoid activation function which has been already discussed in the uh, lectures, which is an linear or smooth curve. Okay, here you may state that there is an directly we have, it is a strict rule actually we have applied it. That is an up, some values is here, then it is an 1, some values is greater less than this threshold, this is an theta is, then it is an greater than, then it is a 0. But in a sigmoid, we'll get as an this like this way a curve, which is an S-shaped curve. This is a smooth curve we are getting, right? Creating, right? So the sigmoid function is most effective in the output layer actually, which is used for the binary classification task, where the output needs to be in range between the 0 to 1. Okay, so here whatever here the z values we are getting as an any infinity or minus infinity to plus infinity. But here after applying the sigmoid activation function, you will get values in between the 0 to 1. Okay, that reason we can say we can use for this confidence score as well. Greater than this zero point 0.5, which is, suppose 0.60, the 0.60 is confidence our of neural network towards the say one class, like this way. Okay, so there is an another reason, the similar way there is another activation function which is an tan h. Okay, so tanh is also actually the preferred of over the sigmoid in the hidden layers of neural network, as it says a zero-centered what we can say zero-centered property, often resulting in faster training. Okay, yeah. So considering this, the activation function, which is an over the sigmoid of activation function, what do you think it is in continuous and differentiable? Yes. But these values is not associated only in between the 0 and 1 in tanh we'll get as an it is zero centered, but which is the negative values is kept it to a negative, and the positive values kept to a positive values. Okay. Yes, anyone? Some students are still joining. So you might be think that what is the boundary, or here in sigma we have seen that the values in between 0 and 1 we are getting the values, but in the tanh we are getting the values in between the -1 to +1. Okay, so here you may see that this is an differentiable equation. Okay, and differentiable equation also it is a continuous values as well. It gives a continuous values, not as we have discussed here. It gives a values, if it is minus as well, but it gives a continuous values instead of this strict 1 or 0 values. Okay, it gives an minus 0.50, 0.50, 0.6, 0.7, like this way, like a confidence score we have discussed in the sigmoid function. But it is a bond, it is in between the -1 to uh, 1 -1 to what we can say -1 to +1. Yeah. Not differentiable. So yeah, someone is saying Neelam, yeah, continuous but not differentiate if it is break for tan h. Break for tan. I'm not understood. What do you mean by? I'm not getting. Can you please elaborate exactly what exactly you are trying to say? Tan h. If it's break the values for tan h function. Break the values for tan h function. Break means it lies in between the -1 and 1. Na? right? Yeah. So may I think I will repeat it. So the definition of the tangent function, that is an actually hyperbolic tangent, which is an tangent function. Okay. So that may be look like this way. Second. Like tan h z is equal to maybe what we can say, ez is equal to e minus z, and that is an ez is plus e minus z. So which this function is continuous if there is no jumps or breaks, that we can say. And yeah, that same you are saying that it is also smooth across all of the z's. Okay. And it is undifferentiable, you may get as undifferentiable values, and which is an 1 minus tan h z, tan h z, and rest to 2, right? So other options, you can say that tan h function is a not a is continuous everywhere, but in option A, you may see that it is continuous and not differentiable, discontinuous and not differentiable, which is an incorrect, right? The tan h is actually continuous everywhere for real values, right? And in option B, it states that discontinuous but differentiable. If a function is not continuous, it cannot be differential, right? Yeah. And in option C, also we have seen that continuous but not differentiable, but it is also incorrect. That is, an tangent is both continuous and okay. Yeah. Okay. Yeah. Uh, Move to the next question. Second. Hmm. Okay, take some time and read this question carefully, which also is trivial. Only needs to put a values, as this is a single perceptron, right? We know the how we can doing a operation in here, which is an x1 into w1 plus x2 into w2 plus bias is equal to the desired output we are getting, right? So take considering these values, also consider the x1 and x2 is which is which are the 0 or 1, and what operation, what logical function you are getting after computing this operation, after computing this formulation along with these values. Okay. Yeah, for your simplicity, I will write here. So x1 into w1 plus x2 into w2 minus 1. Let me solve here. W into, so 5 plus x2 into, yeah, only you have to put x1 is equal to 0 or x2 is equal to 1, what values you are getting. Check for it and you will get an correct option, what exactly it is for the which, for which logical function it computes this perceptron. Yes, anyone? A. Yes. So, any other possible answers are there? Yes, anyone? Yeah. Yeah. Let's see which option is correct. That you may simply put this x1, x2 values. Let's see x0 and 1. What exactly the values we are getting? 0, 1, 1, 0, 0, 0, 1, 1. Okay. So yeah, 5 minus 1, 4 is 5 minus 1, 4, 0, 0 minus 0, 0 minus uh, what I will say here. 0, 0 and minus 1 is and 0. That is means minus 1. This 1, 1, 0, and this 1, 1, 5 minus 5, minus 1, 5 plus 5, 10, 10 plus 9 is then 1. So you can observe that this shows that which is an OR operation, right? Only for 0, 0 you are getting a 0 values, right? So that is an operation B. So OR operation. That's correct. Okay, let's move to the another question. The same question, only the perceptron values, W values has been changed. Here only the bias values has been changed. So considering this, please let me know which option is correct here. The same formulation, sir. Yes, anyone? Yes, anyone has got the answer? Yeah, B. Yeah, it's B option is correct. Please repeat your question. Oh, okay. So here the neural network is given below. This is a perceptron single percent. Two binary valued inputs are there, x1 and x2, which could be the 0 or 1. X1 could be 0 or 1. X2 could be 0 or 1. And the activation function is the binary threshold function, which we can also say that it's a step activation function. Binary threshold means the h of z, this is an h of x we can write here, h of x is equal to 1. When it could be the 1? If whatever the x values, the x input here values, we are getting as an greater than 0. If it is less than, if h of x is equal to 0, when x is less than equal to 0. Okay, x then equal to, sorry, 0. It is an right 0. Yeah. Okay. So this is our activation function, that is step activation function. And here the activation function, as we have seen that, which is an summation of all of these weights, linearly summations of, this is an W1 plus X2, W2 plus bias with their along weights bias weight. So here h of x we are calculating as an x1. Let's, before that we'll put only the weight values. The first weight values is in 5 plus second weight value is in 5 plus minus 8, minus 8. Understood? So here you have to consider x1 and x2 values. Some firstly 0 0 0 1 1 0 1 1. Okay, for four of these cases you have to evaluate that. First we will check for the 0 0 what values we are getting it. So you can see for 0 0 you can put here, I'm getting a 0 and minus 8. So that means it is getting a minus 8, which is an 0, right? For a 0 0 case, I'm only writing here cases. Okay, and let's take for the 0 1 cases, which is an 5. This term is gets 0. Another is an, this is multiplication, the 5 minus 8, which is an also you are getting as an minus 3, which is also 0, right? Considering this activation function. For 1 0 as well, we are getting the 0 value, right? The same formula. For 1 1, you can see the 5 plus 5 minus 8, that means the 10 minus 8, which is an 2, which is an 1. So you can see we are getting as a value as in 0 0 0 and 1. Understood? So it represents and logical operation. I hope you guys understood the truth table or thanks. Yeah. Okay. Yeah. I hope you guys understood. Yeah. Let's move to the next question. Which of the following statement is true for multi-layer perceptron? It's also a trivial question. The first option states that output of all the nodes of a layer is input of all the nodes of the next layer. Okay, I will maybe here visualize this maybe to get easy to understand. It is stating that all of the nodes, this is in three nodes. Okay, all of the nodes of the output of all of the nodes of layer is input to all of the nodes to the next layer. So this is an first layer and this is an second layer, which is also calling as a next layer. And they are giving the output of all of this previous node layer to the input of this layer. Okay, so this is the direction. So the first option states that, which one is correct? The, maybe I will, it is visible, right? Hmm. Little bit I will zoom here. The second option is an all output of the nodes of the layer is input to the all nodes of the same layer. So it is not possible, right? The output is given to the same layer like this way, right? It's not, it is not a actual neural network, actual perceptron, multi-layer perceptron, right? The C option states that output of all the nodes of layer is input to all of the nodes, the previous nodes, previous layer. So it is stating that these are the nodes and these, sorry. Okay, these are the my layers and these are the nodes. So it is stating that these are my, it is going to the backward. It's not also true, right? In the D option, output of all the nodes of a layer is input to all the nodes of the output layer. Output layer, that means it is saying the 1 3 2 1, and this is output layer. Okay, this is the first, second, and this is the last one, which is an output layer. So it is stating that in this output is goes to only these cases. Okay, like this way. Sorry, already. So it's also not true. So here the option is A is correct, right? Meenakshi has answered. The A is correct option here. All of the nodes, output of all of the nodes of a layer is input to a next layer. Okay, subsequent layers. Okay, next last question, maybe second last question. A multi-layer perceptron is usually trained using which of the option? The back propagation algorithm. Okay, it updates the each of the nodes going back, going this they are informing this much as an error. Please update your weights like this way. Okay, so the back propagation, that means in gradient descent, we are mostly used in multi-layer perceptron. Last question, which is about the overfitting, is expected when we observe that. Yeah, it's also trivial. We have seen maybe in the previous slides, in previous classification algorithm. Please let me know which one is the correct option. Okay, I will explain it. So overfitting is an expected when we observe that. Before that, I will recall. Yeah, the Meenakshi has stated that the B is might be correct. Let's see which one is correct. So, what exactly the overfitting, right? So, we have a training set data, right, and we have to design or train artificial intelligent neural network or SVM, any classification algorithm. We need to train us algorithm or any model such a way that that model represents a generalizability. So what you might be think that what exactly the generalizability is there, right? Generalizability means there are multiple cases are there that you have provided set of the examples associated labels and which is an overtrained on the training data. That means overtrain means it will only give correct results on the training data, but it will not give a correct results to a test data, which is an unseen data. Let me visualize here. You have a representation like this way. Sorry, this might be, and this one is another class. Okay, overfitting means it is learned exactly like this way. It is overtrained on the training data. This is our training data. This is our training data. Sorry, overtrained. Okay, but it is not. This is an overfitted on the training data. But if you get a training example here, a test example that is an unseen. Let's see this. This is an class belongs to 0, but it goes this way. But it is also linearly separate. But it is due to extra trained or over what we can say overly fitted. It is not able to correctly classify the new example. This is one problem. Okay. Another case is that underfitting. Underfitting means it is not correctly uh, trained on the training data. This is all the distribution has been sent the training data. So you have a distribution like this way, and you have two classes, right? And zero. Underfitted means you are getting the training result and the testing result as well low. Okay, it's less. So that means it is only simply, it's not underfitted. We are calling as an underfitted. It's not well fitted on the data, right? It is misclassifying the training classes, training set of examples, as well as that is in testing examples as well, right? Because it is not enough for the training set of the data, and how we are confidently stating that it will also work for the testing data, right? Because the testing data also, most of the cases, the follows the distribution of the training data, right? In the some cases it goes out of the bound, but most of that is the first criteria needs to be followed. So this is underfitted. These are the two learning problems that we need to address or look into while we are training the model. And third one is an generalized model. Generalized means it is an not overfitted, not underfitted. Like let's take as an, we have examples. This is an one class, and this is an another class. Okay, so it makes a boundary like this way. Okay, simply boundary like this, not as an overly fitted on the data. So like this way, we want a model that will generalize in the nearly generalize in the new test cases or unseen data. Right? So here, overfitting, it states that someone has given the option B. Let's see the B. With the training iteration, error on training set decreases, but test set increases. Yeah, correctly. You can see here option here, the diagram A. For the training data, it exactly gets a correctly classified data, right? Near about the zero error you are getting here. But for the testing, this is a testing one, it gives an higher error, right? It's not correctly classified. So similarly, it is stated, right? Yeah, I hope you guys understood. This is an last question. So, is there any doubts or any questions? Please let me know now. No, see what exactly the what theoretically the underfitting means. What exactly underfitting means? You are getting training error and testing error is high. That means the training points is also not correctly classifying. In the C diagram, you can see the training examples, training error is less, right? And also it is not overly fitted here. That means like this way. It is generalized line. If it is the values, it falls here. Sorry, maybe it is confusing. Values falls here as well. It tried to find out which class it belongs. Right. It is, if it is here, it also finds the class it belongs. If it is new point is here. Okay. Yeah. So this is that's why we are calling as an C as an generalized fitting. And underfitting, you can see the B option. It is not correctly classifying training data and as well as the testing data. I hope you understood, Meenakshi. Are you getting or not? Okay. Okay. Let me maybe some students may be confused about the ANN, that is an artificial neural network, which is a core of the deep neural network. Whatever the models you are right now right now studying, will study in future as well. So let's take as an the llama, which is an or chat gpt or any large language models. The base is an artificial neural network, right? So the understanding this concept is very important. So it is the LLMs or transformer based model or architecture, neural network architecture is using these neurons, multiple neurons, and various combinations of the neurons. They have designed a algorithm model that can solve any complex problem. Okay, such that you can see the chat gpt can solve any problems that does not, that our whatever query we are asking, that does not exist in the data and training data. Still that in that case, it tries to learn from the or study from the training data, and it can try to infer what is his understanding from the training data, right? Okay, so this is the motivation about the artificial neural network. Also, we are calling as an multi-layer perceptron. Okay, so after this is a basic multi-layer perceptron, we are stating that, but after changing that model, some neurons has been removed, some layers has been added, and the combination has been changed. Based on that, the researchers has been given their separate names, such as convolution neural network, right? Resonate, these are the different neural networks are there. In the transformer based architecture as well, there is an maybe that it's right now it's out of scope, but that is some motivation I wanted to give about this artificial neural network. So you might be think that there are multiple nomenclatures are there, notations are there. For suppose let's we have a input data, right? This is the input, it goes each, this circle represents as a neuron, and and there are multiple uh, the layers are there, right? These are the layers in the fully connected FLC, fully connected FCL, sorry, fully connected layers means this terminology maybe you found in the research papers. In that case, you will get easily understand what exactly this terminology is. So fully connected means each neuron output is connected to all of this is next neuron. So you can see this it is connected to all of the neuron of the next layers. Sorry, next layer, like this way. And that direction is a feed forward neural network. So what we have seen, MLP, multi-layer perceptron, fully connected layer, okay, fully connected layers, FLC, okay, and another feed forward network. Why this differentiation is required actually? Why we are not calling as only NLP, MLEP, multi-layer perceptron? Multi-layer perceptron, what does means actually? Multi-layers means there are multiple layers are there. This is L1, L2, L3, multiple layers are there. Multiple layer which includes perceptrons. Each neuron represents as a single perceptron, right? That's why we are calling multi-layer perceptron. But many time multi-layer perceptron does not guarantee that each of the neurons is connected to all of his next layer nodes, right? So in many in multi-layer perceptron only this node is connected, okay, and this node is not connected to this node, but it is connected to. It's based on the application or based on the problem you are solving. I don't require this node. That is a very competition. That is very doing a competition, or I'm removing some nodes. Right? So this might be included in multi-layer possibility. And why we are calling a fully connected layer? Because all of this connected. If it is not connected, then we are not calling as a fully connected layer. But that is also possibility. If it is not connected, that architecture also you can design based on your problem statement. Fully connected, full feed forward neural network. Right, feed forward means all of this going to upside and forward direction. Here, this section, these layers, that is a middle layers. This is an input layer. Input layer. This is an output layer. Okay. In between this input layer and output layer, middle layers are the hidden layers. Okay. Hidden layer we are calling them. Okay. So you are designing some neural network or deep neural network. that is that is hyperparameter that is in your hand, how much you have to add the hidden layers, how much need to reduce it the hidden layers. More the hidden layer, more the complex model is. Okay, more the neural that we have seen, each neuron is try to get as a linearly separable boundary, right? So you can assume how much neurons you are adding in subsequent layers, that much the model is getting a complex model, right? That is trying to find. The complex model may also you will get better result in complex model, but also may leads to a overfitting as well. Okay. That is some basic terminology I wanted to mention here. So this should be the know about the artificial neural network. I hope you guys understood whatever discussion we have done in this session. Yeah, that's all from my end. Yeah, if you have any questions or query, you may ask right now, or you may also write an mail to me. Yeah, thank you. Let's meet tomorrow as well. We will conduct week 7 tomorrow session, right? Okay, thank you. You may leave this meeting. Thank you.